Good morning, students. Today we are going to see the second subdivision of Unit 5, the quality control and anomaly detection in chemical manufacturing processes. So, the introduction to quality control in chemical manufacturing, the first one goes like this: definition of quality control. So, by the term quality control, you understand the control of quality. For example, when I was doing my internship, okay, the people have tried to do the quality checking for the final product. That is where I was doing the internship in is Asian Paint, Kadalur, where they try to produce the raw material for the paint industry. That pentaerythritol is a compound which they manufacture. So when they manufacture this product, after the final product has been obtained, before packing, they will take out the sample randomly and then try to do the quality check. So when they do the quality check, okay, the quality control is comes into picture. So what are the factors which need to be they need to do in order to do the quality control so that the quality check is get passed. Okay, so the importance of quality control in chemical industry is very important, because otherwise what will happen, the quality will not be with the standard. If the quality is not with the standard, obviously the further processing, for example, the product which I told is a raw material for the Asian paints. So obviously what will happen, that will the quality of the paint will decrease, because the raw material itself is not having a good quality. So the quality control aspect is very important in the chemical industry, because unless otherwise they maintain the process condition and then get the correct yield, okay, otherwise this will not be sell at the final point. So the regulatory standards, another one is regulatory standards like ISO, International Standard Organization, FDA, Food Drug and Administration, GMP, good manufacturing practice. So what is good manufacturing practice? I'll explain to you what is good manufacturing practice. Good manufacturing practice, which stands for good, is a system of regulations and procedures for ensuring that products are consistently produced and controlled to meet quality standards. Is a quality assurance system particularly important in industries like pharmaceuticals and food processing, where maintaining the quality and the safety is crucial. Good manufacturing practices covers various aspects including production, quality control and personal training and documentation. Coming to the key aspect of good manufacturing practices, production and quality control. Good manufacturing practices ensures that processes for production and testing are clearly defined, validated, reviewed and documented. Personals and premises. GMP specifies that personnel are suitable for their task and that premises and materials are appropriate for the intended use. So what are the legal components? The good manufacturing practices has legal components covering responsibilities for distribution, contract manufacturing and responses to product defects. So what are the general principles? GMP principles are applicable to all food processing steps from primary production to the consumer. Coming to the documentation, GMP requires clear documentation of all procedures and instructions, and operators must be trained to carry out and document these procedures. Batch tracking, GMP ensures that records of manufacture including distribution are maintained to enable the complete history of a batch to be traced. Compliance, the GMP guidelines are followed by the manufacturers of medicinal products and active substances, ensuring that medicines consistently meet the highest quality standards. So, the regulatory standards such as ISO, Food, Drug and Administration and good manufacturing practices will help you to achieve the make to have a good quality. Okay, so otherwise they won't approve the thing. Okay, coming to the critical quality attributes, we will see the critical quality attributes in the coming slides. And coming to the tools for quality control, statistical process control, control chart, and parent analysis. So we already know actually what does it mean actually this is statistical process control. Now we'll see what is parent analysis. The parent analysis is a decision making tool premised on the idea that 80% of the project benefit can be achieved by doing 20% of the work, or conversely we can say 80% of the problems can be traced to 20% of the causes. So parental analysis, also known as 80 by 20 rule, which is used to identify the vital few factors that contribute to the majority of the problems, causes, or an outcome effects. It is a decision making technique that helps prioritize efforts and resources by focusing on the most impactful areas. So problems and prioritization. So the more detailed look of new parental analysis goes like this. First one is problem solving and prioritization, identifying the root causes. Parental analysis helps determine which specific factors contribute to most significantly to a problem, allowing for focused problem solving efforts. Prioritizing tasks by focusing on the vital new factors, parent analysis helps prioritize the task and allocate the resources effectively. Decision making, it guides decision making by highlighting the most impactful areas for improvement or resource allocation. Business application. The second part, it also used in the business application. So how it works, we don't get into that business part. Okay, we'll get into how it works. Data collection. Parental analysis begins by collecting the data on the frequency of different factors or causes. Data categorization. The data is then categorized and ranked by frequency of occurrence. Visual representation, that is a parental chart. The results are often visually represented in a parental chart, a bar chart graph that shows the frequency of different factors in descending order. So the analysis, the chart helps identify the vital few factors that have greatest impact for allowing for focused problem solving or resource allocation. So this is called 80-20 rule. Parental analysis is called 80-20 rule. Coming to the definition of the quality control. Quality control is set of procedures or practices aimed at ensuring the chemical products meet defined standards. So chemical products meet defined standards. Underline the word chemical products meet defined standards of quality. So as I told you, so quality control they will do, okay, not only after checking the quality of the product, okay, they will maintain the quality control in every each and every process, okay, so that the final product quality will not get affected. Okay, that is the main idea. It involves monitoring manufacturing process, just now I told, right? So it's a monitoring the manufacturing process, so they will be very precise. For example, they have a reactor. This need to be operated at a standard temperature, at particular temperature and pressure, and the flow rate is supposed to be in that particular rate. The feed temperature, temperature is supposed to be this one. Okay, they will all maintain the same thing. Otherwise, if there is any deviation, that will be reflected in the output. Okay, I just take an example of batch reactor and giving an example. Just imagine this need to be maintained from the starting of the process until the end of the process. So you have a different unit operation and unit processes that need to be maintained. So detecting the deviation or defects and implementing the corrective action. So try to find out where the deviation occurs and what are the defects and how to overcome that one. Implementing the corrective action. Implementing the corrective action in the sense when the temperature is not maintained inside the reactor is constant. Okay, so what are the things they need to do in order to make that is consistent. So obviously the product will be with a good quality. So the goal is to produce consistent, safe and compliant products while minimizing the waste and variability. So the main goal of this quality control is to produce consistent, safe and compliant products while minimizing the waste and variability. So the importance of quality control in chemical industries. Quality control is critical in chemical manufacturing due to health and safety, regulatory compliance, customer satisfaction, cost efficiency and process optimization. So what is the necessity of doing the quality control? Because the main thing is the product quality. Okay, there is no compliance, there is no what you call uh, any deviation they don't accept. Okay, so the product quality is supposed to be high. The health and safety, so the workers, okay, the health and the safety of the process, that is very very paramount of the any chemical industries. So the health and safety, the chemical products often involve hazardous materials. Quality control ensures safety for end users and operators. So the deviation, for example, the pressure need to be maintained at 8 bar. Okay, so if it is more than 8 bar, okay, obviously the product quality will goes out, as well as the safety of the thing is very important, because if the 8 bar is more than the 8 bar, the whether the equipment could be able to withstand the higher pressure or not, that is another question. So if it goes, is there any blast are taking place? There is chances. So the safety aspect also they need to consider. Okay, coming to the regulatory compliance, industries must comply with this strict regulation. For example, most of the industries they not deploy in inside the US judiciary because they need to follow a standard like US EPA, United States Environmental Protection Agency, and they are based on the Food and Drug Administration. Most of the pharmaceutical industry, if you see, they don't keep it inside the US. They have their own technology available, but they will try to deploy in the developing countries like India or Indonesia, okay, or even in China. Okay, so the main purpose right now is to safeguard their environment. Last time when the person who comes actually for IECG talk. Okay, he was discussed about the people have discussed about the pharmaceutical industry. Okay, and then they told actually clearly why they are not they're not putting inside the jurisdiction of US, even though the technology belongs to them. Okay, so that is one point we need to keep in mind. And coming to the EPA, the regulatory company is very very important. Unless the product could not be approved. Okay, the customer satisfaction, high quality products enhance trust and loyalty. Cost efficiency, detecting defects yearly reduces rework, waste and recalls. So we try to find it out the what is the defect, okay, yearly stage itself, so that we don't need to rework on it, and then the waste will be minimized and recalled and come back again and recall the things. Okay, that will not, okay, need not occur. Okay, so the process optimization, quality control data helps improve production efficiency. So process optimization. So if you need that will help you to quality control will help you to optimize the process. Okay, so that means maximum effort that will give the output. Okay, so quality control data helps improve the production efficiency. Coming to the regulatory standards and guidelines, to maintain quality, manufacturers follow international standards like ISO 9001, focuses on quality management system. Okay, good manufacturing practices set by Food, Drug and Administration and WHO, World Health Organization, crucial in pharmaceuticals and food. ICH Q8, Q9 or Q10 guidelines for quality risk management in the pharmaceutical industry. REACH and OSHA, Chemical Safety and Environmental Protection Regulation. Example, a pharmaceutical manufacturer must maintain consistent pH levels in a drug formulation. Deviation could make the product ineffective or harmful. Just now I give an example in a batch reactor, like keeping a temperature inside the reactor is consistent. Similarly, here they have say for for this process the pH levels in the drug formulation supposed to be maintained consistent. Otherwise, what will happen? This there is a deviation could make the product ineffective or harmful. So regulatory, I mean maintaining the variables, okay, in a process is very very important in terms of safety aspect and terms of what you call the quality of the product and so on and so forth. And coming to the quality, critical quality attributes, these are the physical, chemical, biological or microbiological properties that must be controlled with specific limits. So the critical quality attributes, example, okay, pH level, viscosity, reaction temperature, purity or impurity profile, particle size, distribution. So control quality attributes are defined during product development and become key matrices for ongoing quality control. And several tools are used to monitor and maintain the quality. One is statistical process control. Use statistical methods to monitor process behavior, helps detect anomalies and maintain control limit. Control chart like track specific process parameters over time. Example, XR chart, that is it, X bar or R chart is a mean and range. P chart, proportion and defective. Pareto analysis, as I told you, 80-20 rule, identifies the most common sources of defects, helps prioritize the efforts for quality improvement. Histogram and scatter plot help visualize the distribution and the relationship between the variables. So this histograms in the previous lecture, I mean in the lecture 1, I mean in the unit 1, we have discussed the histograms and scatter plots. Okay, that is even the scatter plots you can draw in Excel sheet, Excel. Okay, so these are the things. So helps visualize the distribution and relationship between the variables. And coming to the root cause analysis tool, fishbone diagram. So the fishbone diagram, I think you have heard about it. Okay, so I just give you a definition for fishbone diagram. Okay, meanwhile, you just think of what is a 5 why techniques. So the fishbone diagram, okay, actually is a Ishikawa diagram. Ishikawa in means is a Japanese word that is fish. Okay, fishbone diagram. Okay, they are also called fishbone diagrams. Okay, herringbone diagrams, cause and effect diagrams is the other name for fishbone diagrams. Cause and effect diagrams or herringbone diagrams or casual damage created by the coral Ishikawa that is shows a potential cause of the specific event. The common uses of this fishbone diagram are product design and quality defect prevention to identify potential factors causing an overall effect. Each cause or reason for imperfection is a source of variation. Causes are usually grouped into major categories to identify and classify these sources of variation. So, what we understood from this, the quality control, there are several tools to monitor and maintain the quality. One is a statistical process control, another one is control chart, Pareto analysis, histogram and scatter plot and root cause analysis. Okay, so please try to understand the things, okay, which we have discussed so far. Let's say I give an example for realistic understanding about the content which has been delivered so far. One is the pharmaceutical industry. The main objective of the pharmaceutical industry to maintain a drug concentration, so that can be tested in UV spectroscopy, which ensures dosage accuracy. Coming to the paint manufacturing, so the viscosity is very important quality control parameter. So the test meter is a testing used is a rheometer to make the control consistency. Okay, control consistency of the paint. So the viscosity is varying, it's very light or is increased, obviously that will be reflected in the quality of the that shows the quality of the paint. Okay, coming to the food industry, the pH meter plus statistical process control. The tool used are the pH meter ensures shelf life and taste. Fertilizer production, nitrogen content, this can be tested by titration, meet nutrient specifications. Okay, so the summary of this so far, what we have seen is the quality control. The quality control is a foundational for reliable, safe and compliant chemical production. It relies on well-defined standards, process monitoring and statistical tools. Understanding quality control quality attributes and regulatory expectation helps build robust quality systems. Coming to the example, okay, let's say I just don't want to get into the things how it need to be carried out. I will tell you the two examples, okay, how to carry out this what you call the task for the problem. Okay, that I will explain to you. Let's imagine a reaction yield and anomaly detection. So the deviation actually from the normal data. So in a batch reactor producing ethyl acetate. So how the ethyl acetate will produce will be getting produced acetic acid plus ethanol gives ethyl acetate and water via esterification process. A plant consistently achieves a 90% yield. Okay, however, in the last three batches, the yield dropped to 78%, 74%, and 76%. So there is a esterification process is going on inside the reactor. Okay, during that process, the yield is supposed to be 90% yield, that is ethyl acetate, but unfortunately, the yield has been dropped to 78%, 74%, and 76%. So the normal operational temperature is 60°. Catalyst is sulfuric acid is supposed to be catalyst is sulfuric acid and the concentration they have given as 0.1 mole per liter. The molar feed rate, that is ethanol and acetic acid, the ratio is 1:1. The conversion and yield are calculated using the titration method on samples. During this titration method only they have found out the yield has been reduced from 90% to 78%, 74% and 76%. So what is the root cause for this? So why there is a deviation occurs? Apply the mass balance principles to identify the possible sources of yield loss. So whether the mass balance will help you to identify the possible sources of why the yield has been getting lost. Okay, suggest a quality control strategy using control chart to monitor the key parameters and detect the anomalies. So when you try to add the data and try to find is there any deviation of the data from the mean data or the skewed data or something which is deviated from the normal, that can be found out, okay, by using the control chart. That is a quality control strategy using control chart to monitor the key parameters and detect the anomalies. And how would least Chatterjee principle guide process adjustment to restore the yield? So to restore the yield, how the what is the technique we have, as per the chemical engineering principle like least Chatterjee principle? Okay, guide in adjusting the process adjustment to restore the yield. Coming to the second case, question 2. Control of pH in a continuous neutralization process. The scenario, a continuous set tank reactor is used to neutralize the sulfuric acid stream with sodium hydroxide. So, the CSTR is used to neutralize the sulfuric acid by adding a sodium hydroxide. So, sulfuric acid plus sodium hydroxide gives sodium sulfate and water. The pH of the effluent must be maintained between 6.5 and 7.5. So, this is acidic, that is base. So, it's supposed to come between 6.5 to 7.5. This is a neutralization process because one is acid base titration, right? So, when you see here how to control the pH in a continuous neutralization process, the given condition for this process has been given as flow rate of sulfuric acid is 5 liters per minute, concentration is 0.5 molar, flow rate of sodium hydroxide controlled via a valve, a pH sensor data is available in real time. So this task is derive a stoichiometric relation to calculate the required sodium hydroxide flow rate. The second one, design a feedback control strategy to maintain the effluent pH within the acceptable range. So if there is a deviation, obviously it will give you an alarm. Okay, design a feedback control strategy to maintain the effluent pH within the, so is alarm in the sense what? It will feedback control strategy. So it will increase the sulfuric acid. For example, if it is more acidic, the base will be added. If it is more basic, acid will be added. Design a feedback control strategy to maintain the effluent pH within the acceptable range. Propose a method for anomaly detection in the pH control system, sensor drift or valve failure. Um, so these are the proposed methods. So this will help you to make sure that neutralization process occurs effectively. Okay, so coming to the anomaly detection. How to do the anomaly detection? Anomaly detection is the identification of unusual patterns or deviation from the normal behavior of the process. In chemical manufacturing, anomalies often signal equipment malfunction, sensor drift or failure, process instability, safety hazards, product quality issues. The objective to detect the abnormal events yearly so corrective action can be taken. So if you identify the detect the abnormal events yearly, so corrective action can be taken, minimizing the downtime, waste time or hazards. So I mean, otherwise what will happen? The corrective action not taken, the quality control is again an aspect. So the quality control aspect again a safety and optimization is again a question mark. So is the one or other way related. So we should make sure the process has been carried out in a prescribed stated condition. Otherwise, the deviation obviously will occur. Try to identify the deviation and try to find out the root cause for that for the deviation and try to control the parameters under our control so that the maximum effort, I mean maximum quality can be achieved during the process, as well as the safety aspect will be good and so on and so forth. So you understand what for we are doing actually all this anomaly detection in chemical process, because it's to make sure the process quality is maintained at a consistent as per the regulatory standards or as well as the requirement of the users. Okay, so the types of anomalies, the point anomalies, contextual anomalies, collective anomalies. What is point anomalies? For example, a single data point significantly deviates from others. So let's say you have a try to maintain a temperature in a inside the reactor. It shows is supposed to be 60 degree, and the sensor shows 60 degree, sometimes 61 degree, 59 degree. Okay, well and good. At least it shows in very close to the 60 value. Suddenly, if it shows some 120 degree, a sudden spike in the reading in the reactor. Okay, is an anomaly. It's a point anomaly. That means if it shows 55 or 65, is small deviation from 60. But if it suddenly shows 120 degrees, something went wrong. Okay, so either it may be a sensor problem or it may be real conditional problem inside the reactor that we may not be doing. So this anomaly need to be noted down, and the corrective action supposed to be taken. Coming to the contextual anomalies, a point data that is anomalous in a specific context, example, time, condition, high flow rate during a shutdown period. Let's say a point data that is anomalous in a specific context. So, with respect to time or with respect to condition. So, here is a condition. I mean, it's a time. Shutdown period is a time. Okay. So, during the time, the high flow rate has been obtained. Collective anomalies, a group of data points that together deviate from the normal behavior. Example, gradual drift in pH values across several batches. So the collective anomaly is a group of data points that together deviate from the normal behavior. Gradual drift in pH values across several pHs. So it is not only one batches, it is across the group of data has been deviating. These are collective anomalies. Okay, coming to the rule-based method versus data-driven approaches. Rule-based approaches use predefined threshold or business logic, easy to implement and interpret, limited flexibility and prone to false alarms. So rule-based approach. Okay, so what is rule-based actually? Actually, the alarm when temperature is greater than 150 degree, that need to be done. There is an example for the rule-based approach. Use predefined threshold or basic logic. So if it is good, just now I told you for 60-degree batch reactor, if it is shows 120 degree, obviously it will need to be with the alarm. Okay, meaning to say if it is a 60 degree need to be maintained, 55 or 65 is there is a fluctuation is okay. If it is more than 65 or less than 55, the alarm need to be done. Okay, so here in this case they have given alarm when temperature is greater than 150 degrees Celsius. So rule based approach use predefined threshold or business logic. Easy to implement and interpret. So rule-based approach is easy to implement and interpret things. Limited flexibility and prone to false alarms. Data-driven approaches use statistical or machine learning models to learn patterns from historical data. Better performance in complex and non-linear systems. So data-driven approach use statistical or machine learning models to learn patterns from historical data, better performance in complex and non-linear system. Example, train a model on normal process behavior and flag deviation automatically. And coming to the statistics techniques for anomaly detection, first one is Z-score method. Let's say assume the data is normally distributed, flag values that deviate by a certain value that can be calculated by Z is equal to x minus mu divided by sigma. Okay, so the mean standard deviation use case is simple threshold reduction in pressure or temperature sensors. If they are simple threshold reduction in pressure or temperature sensor can be used by the use case. Okay, here they have given the isoscore method. Coming to the principal component analysis is a dimensionality reduction, reduces data dimensionality, identify the correlation between the process variables. Okay, and then anomalies are detected when data points fall outside the expected variance space. So just now I told 60 degree, 55, 65, okay. If it is more than 65 less than 100, it's outside the expected variance space. So the variance is 5. So 60 degree, 5 degree lower or 5 degree higher is okay, well and good. But anomalies are detected when data points fall outside the expected variance space. So that is called anomaly. So if it is within the variance space, we don't have any issue. Okay, even the marks when the people have been evaluated paper, they should have a variance standard deviation maybe 12 to 13 will be there. It's a very good indication. That means if this deviation between the marks between the students among 100 is a 12 to 13, that means the paper has been properly corrected. That's the statistical meaning of the things. Okay, if the value is very close, maybe the student might have done very close to the things, but however is not need you could not able to get a normal distribution curve. Okay, so you just try to understand. So what I'm trying to say. So coming to the time series analysis, models temporal behavior of variables with ARIMA or exponential smoothing, detect anomalies like unexpected spikes, trends or shift. The time series analysis models temporal behavior of variables with ARIMA or exponential smoothing. So we have, I already told you what is ARIMA. Okay, so I just get back to you with the ARIMA model. There is a auto-regressive integrated moving average model. It is a statistical technique used for time series analysis and forecasting. It combines auto-regressive and moving average models to predict future values based on past data and errors. The I in ARIMA refers to the integration step where differencing is applied to make the time series stationary. Here is the key components. So the key components are autoregressive, integrated, moving average. Okay, autoregressive AR, integrated means I, moving average means MA. So this part of the autoregressive, this part of the model uses past values of the time series. So time series we have already discussed in unit 4. Okay, to predict the time series to predict the future values. It assumes that the current value is related to the previous values. So that is the autoregressive. Coming to the integrated, this component involves differencing the time series data to make it stationary. Stationarity means the data has a constant mean and variance over time and its autocorrelation structure is consistent. Moving average, this part of the model uses past errors like residuals of the time series to predict failure values. It assumes that the current value is related to past forecast errors. How it works? Data preparation. The time series data is first analyzed to determine if it is stationary. If not, differencing is applied to make it stationary. The model selection, the orders of the AR, that is autoregressive, I and MEA components are determined based on the autocorrelation and partial autocorrelation function, okay, of the time series. Model fitting, the ARIMA model is then fitted to the data using statistical techniques. Forecasting, once the model is fitted, it can be used to make future prediction. So the application of ARIMA model is in finance, business, energy and other things. So I just would like to highlight energy, forecasting electricity consumption, demand and prices. So the advantages is simplicity, interpretability and efficiency. ARIMA models are relatively simple to understand and implement. Interpretability, the parameters of the model are easily interpretable, making it easier to understand the underlying dynamics of the time series. Coming to the efficiency, ARIMA models can be computationally efficient, especially for short-term forecasting. Coming to the limitation, the linearity. ARIMA models assume a linear relationship between the time series and its past values, which may not always be the true. Okay, so there may be a non-linear model also available, right? So the stationarity, the integration step requires the time series to be stationary, which may not be always be the case. Model selection, choosing the correct orders for the AR, I and MEA components can be challenging. So the time series analysis model temporal behavior of the variables using the ARIMA. Okay, detect anomalies like unexpected spikes. So these are all coming under the statistical techniques. So what I would like to say, for anomaly detection, Z-score method is there, principal component analysis is there, and time series analysis is there. Coming to the machine learning techniques for anomaly detection. So first point is isolation forest, autoencoders, long short-term memory networks. What is isolation forest? And as in simple is a unsupervised method, right? Unsupervised learning. Yeah, an ensemble based unsupervised method and isolate anomalies by recursively partitioning the data. The strength is very fast. It can handle high dimensional data. Autoencoders is a neural network. Okay, it is a coming under a what you call supervised learning. Okay, train a neural network to reconstruct the input data. Large reconstruction error indicate an anomaly. Use case, detecting suitable subtle anomalies in complex sensor data. Long short-term memory networks, a type of recurrent neural network suitable for sequential data. Predict future time series values and detect deviation. Use cases, detecting anomalies in real-time sensor streams. So the machine learning techniques like isolation filters, autoencoders, long short-term memory will help you to identify the anomaly detection. Machine learning techniques for anomaly detection. So coming to the examples. So in a process, immediately in a process, you have a distillation column, batch reactor, mixing process, pH neutralization, okay, so on and so forth, right? So when you come to the anomaly for distillation column, the flooding, the PCA, principal component analysis with the control chart. Okay, this one is a statistical technique. Okay, so it's not a machine learning technique. It's a score or LSTM is a long short-term memory which has been used for speech regulation and so on and so forth. As I told you, or tone regulation. Okay, so the back tone spike or not recognition, tone spike or speech recognition. Okay, so the batch reactor, temperature spike or isoscore or LSTM, mixing process, viscosity drift, autoencoder or real-G data detection method, pH neutralization, sensor, the anomaly is sensor drift that may happen that can be detected by means of the statistical process monitoring. So what are the different types of detection methods is that one is statistical method and another one is machine learning methods which can try to help you to detect the anomaly, that is a deviation. Okay, so where the deviation occurs in digital, I mean, it's one of the case is a flooding. Okay, so batch reactor, temperature spike, mixing process, viscosity drift. So any process will have a detection and anomaly means deviation. Anomaly is a deviation. Okay, deviation from the normal data. So that may occur. So for which how to detect the things. Detection method has been given for you. So what are the challenges in anomaly detection? False positive, false negative. Okay, so we have given many examples actually the false positive and false negative, how to differentiate the difference between the precision and accuracy by means of false positive and false negative or true positive and true negative. Okay, so this all we have discussed actually in what do you call it, very elaborately during the previous classes. Okay, so false positives, flagging normal data as anomalous. Okay, flagging normal data as anomalous. And false positive. False negatives, missing real anomalies. Concept drift, normal behavior changes over time. Example due to catalyst aging. Lack of label data, supervised model for recur historical anomaly labels. Lack of label data, supervised models recur historical anomaly labels. Okay, that is very, very important. These are the challenges in anomaly detection. Best practices and recommendation. Combine rule-based methods with data-driven techniques. Use domain knowledge to select the relevant process variables which are more predominant. Okay, what are how the process variable, one process will affect the other process. It's all we supposed to know. Periodically update the models to account for process changes. Integrate the anomaly detection with the control system for automatic alert. Visualize the anomaly scores for better interpretability. These are the best practices and recommendations. Okay, for the anomaly detection. Coming to the summary, the anomaly detection is essential for modern chemical manufacturing. Okay, to ensure the product quality, reduce the risk of equipment failure, improve the process safety and reliability by using both statistical and machine learning methods. Okay, for the anomaly detection, manufacturers can automate the detection of unusual behavior and take proactive measures. So immediately they want to take a preventive measures or proactive measures so that this will not happen. Even the people will try to find the time series analysis data and forecast the thing whether the deviation how to the what do you call it, how to control that particular anomaly. Okay, so by either by the statistical method or by means of the what you call the machine learning techniques. So the anomaly detection is essential to ensure the product quality, because if there is any deviation, that is obviously lose the product quality, stand with the standard product quality, reduce the risk of equipment failure. Okay, so the equipment failure, as you told me, the pressure is greater than 8 bar. Okay, so there may be a blast may takes place. Okay, so the reduce the risk of equipment failure, improve the process safety and reliability. Okay, so improve the process safety and reliability, these are the factors of actually essential. Anomaly detection is essential for doing for modern manufacturing to ensure product quality, reduce risk of equipment failure and improve the process safety. Coming to the case study, sensor fault detection in heat exchanger system. So there is a problem, background is given, investigation and findings. Okay, and what is the corrective action? Similarly, I'm just going to show you the two examples for this sensor fault detection in heat exchanger. So let's say the heat exchanger is showing a fault in sensor fault. A shell and tube heat exchanger is used to preheat the feedstock before entering the reactor. Let's imagine the reactor need to have a feed temperature of the product supposed to be, I mean the feed temperature of the mixture supposed to be 60 degree. Okay, so that is not a 60 degree. So we are just trying to heat up the mixture to 60 degree and let it out, get into the, make them to get into the reactor. Okay, so the cell and tube heat exchanger is used to preheat the feedstock before entering a reactor. The temperature at the outlet is monitored by multiple sensors to ensure consistent heat transfer. Okay, so the temperature at the outlet is monitored by multiple sensors to ensure the consistent heat transfer. So the is a outlet is actually is a heat cell and tube heat exchanger. So cell and tube heat exchanger is used to preheat the feedstock. Okay, before getting into the reactor, the temperature at the outlet of the heat exchanger is monitored by multiple sensors. to ensure consistent heat transfer. So here the temperature is the outlet of Stellar tube heat exchanger, not the reactor. Okay. So the problem is operators notice a gradual drop in outlet temperature reading from one sensor over several diffs. Okay, the operator notice a gradual drop in outlet temperature. The outlet temperature of the heat exchanger is has a gradual drop readings from one sensor over several shifts despite no change in process condition or stream input. So as you shift a heat exchanger, the cold in, cold out, hot in and hot out, the temperature has been fixed. Obviously, there will be heat transfer takes place. If there is any fouling or the heat transfer, because of that, the heat transfer efficiency will be reduced. Okay, so we may not be knowing actually why this output of the stream is not maintained at a particular temperature, even though we don't change, there is no variation in the input. Obviously, we need to identify that root cause, right? So what they are trying to say here, the operators notice that the outlet of the heat exchanger is gradual drop in outlet temperature reading from one sensor over several shifts. So when they try to process is not consistent, despite no change in process condition at or stream input. This caused the feedback control system to overcompensate, increasing the steam flow unnecessarily and raising the energy cost. So that means if it need to come at 60 degree, enter into the reactor, but unfortunately it's not 60 degree is not maintained. So obviously they are just passing the steam in order to increase to from 58 to 60. Okay, so from inside this cell and tube heat exchanger itself. So just imagine this caused the feedback control system to overcompensate, increasing the steam flow unnecessarily and raising the energy cost. Okay, coming to the investigation, why this is occurred. Statistical process control applied control chart on the temperature sensor data of the cell and tube heat exchanger. Principal component analysis compared the faulty sensor to others to identify the deviation from the correlated behavior. Findings: the faulty sensor exhibited sensor drift, a slow progressive error not visible with the threshold based alarms. Principal component analysis flagged it as an outlier in the multivariate model, though the drift was within the sensor's raw specification range. The faulty sensor exhibited a sensor drift. Okay, so why this is a faulty thing? Okay, so a slow progressive error not visible and threshold based alarms. Principal component analysis flagged it as an outlier in the multivariate model, though the drift was within the sensor's raw specification range. So please try to understand the findings. Okay, and the corrective action, what they do, the sensor was recalibrated. So the problem with the sensor, they identified the problem with the sensor, it has been recalibrated. Despite it shows 60 degree, but it shows 58 degree. There is sensor problem. So the redundant sensor and anomaly detection alert was added to the system. Coming to the chemical engineering principle use, heat transfer, despite the sample utility, input and design, delta T discrepancy pointed to measurement issues. Redundancy and reliability. Chemical engineers applied reliability concept to add backup sensing and improve the fault tolerance. So the redundancy and reliability. Okay, chemical engineers applied reliability concepts. Okay, to add backup sensing and improve the fault tolerance. So they may keep the another sensor. Okay, if there is a sensor failure, how can we check? We can calibrate or do it again, or else you just keep this second sensor and try to find is there any deviation in the sensor values. Okay, so that means the temperature values by the sensor. And coming to the second part, the case study, batch to batch consistency monitoring in polymerization. In a batch polymerization reactor, okay, do producing polyethylene is a polymer compounds. Parameters like monomer feed rate, temperature and agitation speed must be tightly controlled to ensure the consistent molecular weight and viscosity. In a batch polymerization reactor, parameters like monomer feed rate, temperature and agitation speed must be tightly controlled to ensure consistent molecular weight and viscosity and the polymer compound which has been formed. So the several batches failed to meet the viscosity specs even though all the set points were within the acceptable range. The deviation were unpredictable and costly. So why this deviation occurs? The viscosity specs is not meet the consistent. That is the problem. Coming to the anomaly detection. So autoencoders like a deep learning, okay, that is autoencoders is a machine learning models for detecting the anomalies trained on historical normal batch data. Previous data, they tried to train the thing. The model monitored multiple time series variables like temperature, monomer feed rate, pressure, and stirrer speed to detect the abnormal pattern. Why the viscosity is not matching? Okay. So the finding shows that the model detected anomalous behavior in early phase heating in the failed batches, slightly slower ramp up rate. This caused incomplete reaction initiation and lower polymer chain growth. And coming to the root cause, case study 2, batch to batch consistency monitoring in polymerization. A manufacturing stream value actuator delayed heating during early batch stages. Corrective action, the steam valve actuator was replaced. Real-time anomaly alerts were added to the early batch phase. Chemical engineering principles used are polymer reaction kinetics. The rate of polymerization is temperature dependent, especially in initiation. Process dynamics slightly delay in achieving the reaction temperature effect. End product quality significantly in batch system. So, what is the root cause? A manufacturing steam valley actuator delayed heating during the early batch stages. So, in the early batch stages, the steam valley actuator delayed so that the heating is not effective. The steam wall actuator was replaced. Okay, real-time anomaly alerts were added to the early batch phase. Chemical engineering principle is polymer reaction kinetics and process dynamics. The rate of polymerization is temperature. Okay, temperature different, especially in initiation. So if it is a temperature different, the steam wall actuator is not properly maintained. Obviously, the output of the rate of polymerization is less. Process dynamics slightly delay in achieving the reaction temperature effect. Affect reaction temperature, affect the end product quality. Okay, so reaction temperature need to be maintained. Okay, otherwise the end product will be affected. So here in E-stage engine, the sensor drift. So because of the sensor need to be replaced. The principle is chemical engineering principle is heat transfer and control. So the direction anomaly is principal component analysis and statistical process control. Coming to the polymerization process case study, the batch inconsistency because there is a variation in temperature. Okay, autoencoders will detect the anomalies and that the root cause, I mean the principle is kinetics and process dynamics. So hope you understood. So what is the quality control? What is how to detect the anomaly detection? Okay. So these are the things which we have seen in today's lecture. I stop it here. I believe that you understand so far what has been covered. Okay, quickly I would like to what you call wrap the content which has been delivered so far, almost more than 45 minutes. Okay, so just see here. So the topic will go to the content or this is a second subdivision, quality control. What is quality control? Okay, what is the necessity of doing a kind of quality control? Otherwise what will happen to the process, okay, to the product quality, that we need to know, and what are the methods to do the quality control. Okay, and then how to detect the anomaly detection, that means deviation from the normal. So what are the root cause for that? Okay, how to identify by means of a, statistical anomaly detection or by means of machine learning anomaly detection. Okay, in chemical manufacturing process with the examples we have seen. So, okay, so hope you get an idea about it. What is the importance of quality control or anomaly detection in chemical manufacturing process? With this, I just would like to wind up this section. Hope you we will see in next class. Thank you very much.